Hello, this is Dr. Hanaa Assil, and this is Unit 2, October 2024, in the Pearson Edexcel International A-Level Chemistry. So, let's take a look at the questions and discuss the answers. A Maxwell-Boltzmann curve showing the distribution of molecular energies is shown. So, this is a Maxwell-Boltzmann distribution curve. What happens to the curve when the temperature is increased? Remember that when we increase the temperature, what happens? All the particles have higher energy, so the whole curve shifts towards the right, but the total number of molecules is the same, so the peak has to go down. So which of these is correct? The peak becomes lower and further to the right. This is with increased temperature. Now, how does the diagram change if a catalyst is added? Remember, what does a catalyst do to the Maxwell-Boltzmann distribution curve? Well, you should remember that a catalyst provides an alternative pathway with a lower activation energy. So what happens is the activation energy moves to the left and the peak stays the same. We're not changing the peak. The equilibrium between methane and steam is shown. What would be the effect of lowering the temperature? So this is a reversible reaction, and we are told that the delta H for the forward reaction is positive. That means the forward reaction is endothermic. Now, when we lower the temperature, you should know, in any reversible reaction, when we lower the temperature, it goes to the side that is exothermic. So in this case, lowering the temperature will cause the point of equilibrium to shift to the left or go backwards. That means the yield of product would decrease. So what happens to the rate? You should know that lowering the temperature will always lower the rate. So rate decreases, and at the same time yield decreases because the equilibrium shifts backward or less product is formed. What would be the effect of increasing the pressure on this reaction? Well, when we increase the pressure, you should know the point of equilibrium goes to the side with less moles. So which side here has less moles? If we increase the pressure on this reaction, it will go backward, or the point of equilibrium shifts to the left, because this is where we have less number of moles. If we go back, we make 1 mole methane, 1 mole water. If we go forward, we make 1 mole of carbon monoxide and 3 moles of hydrogen. So going back gives less number of moles. What about the effect on the rate? You should remember that always increasing the pressure increases the rate because particles are nearer to each other. So increasing the pressure increases the rate. What about the yield? Well, in this case, it causes the point of equilibrium to go to the left, so less product is formed, so the yield decreases. Some bond enthalpies are shown. What is the bond enthalpy of the CH bond? So we have this reaction which involves CH bonds in the CH4, OH bonds in the water, C triple bond O in the carbon monoxide, and HH bonds in the H2. So and we're told that the total delta H is plus 206. So the only thing that we don't know is the CH, so you should realize that reactants minus products is equal to the delta H. So in the reactants, we have 4 CH bonds, we have 2 OH bonds, that's what we have in the water, minus the products, minus the bond enthalpy for the CO and the bond enthalpies for the 3 hydrogens. All of this is equal to 206, so we can just solve for the CH bond. one CH bond. Of course, what comes out here, you're going to divide by 4. So that is 415.8, which is the same as 416. Which equation shows the reaction that occurs when the standard enthalpy change of formation of copper carbonate is found? We want an equation for standard enthalpy change of formation of copper carbonate. You should realize standard enthalpy change of formation is the enthalpy change that takes place when 1 mole of a compound is formed. So we're looking for the equation that gives 1 mole. So B is wrong. That second option is wrong. We want to make 1 mole of copper carbonate in its standard state. Okay, all of them have copper carbonate as a solid, and that's correct. From its constituent elements in their standard state. So what are its elements? Copper. What is the standard state of copper? Copper is a solid. Carbon. Carbon is also a solid. Oxygen is O2. Not oxygen atom, O2, and it's a gas, so this would be the equation for the standard enthalpy change of formation of copper carbonate. Which statement about group 2 elements and their compounds is true? So we're comparing group 2. Calcium hydroxide is less soluble than magnesium hydroxide. Is that correct? Well, we said if we're talking about hydroxides, the hydroxide is regarded as a small ion. So with a small cation, it is more strongly attracted and less soluble. So actually, it's the magnesium hydroxide that is less soluble than calcium hydroxide. Calcium hydroxide would be more soluble. All group 2 metals give a characteristic flame test color. Is that correct? You should remember that magnesium does not give a color. We said magnesium burns with a white flame or a bright flame, but no color. Magnesium carbonate does not thermally decompose. Well, let us take a look at the stability or the ability to decompose. You should realize that carbonate is a big anion, so with the small cation it will decompose more easily. So actually magnesium carbonate decomposes more easily than calcium carbonate or barium carbonate. What about the first ionization energy of magnesium? Well, if we compare first ionization energy of magnesium and that of calcium, yes, you should realize that magnesium would be greater because the electron to be removed is nearer to the positive nucleus since it's a smaller atom. So magnesium has smaller atomic radius. The electron to be removed is more strongly attracted to the positive nucleus, so it will need more energy to be removed. So yes, its first ionization energy would be greater than that of calcium. A compound which is a white solid. So we're starting with something white, that's okay, or our choices are white solids, gives a red flame test. So what gives red flame tests? Well, we have lithium is red, strontium is red, and calcium also is sort of red. It's brick red. So we can take that into consideration, but of course we cannot choose sodium. Sodium is definitely yellow. It is nothing near red. So, well, it is strontium or it could be calcium. Produces a colorless gas when heated. Well, you should realize that nitrates of group 2, like calcium nitrate and strontium nitrate, they will produce, okay, an acidic gas, but it is reddish brown. It gives nitrogen dioxide gas. So when we heat calcium nitrate and strontium nitrate, it will give reddish brown gas. But calcium carbonate, when it is heated, it gives a colorless gas, which is carbon dioxide, which is acidic. The nitrates will give nitrogen dioxide gas, which is acidic, but it is reddish brown. So the choice here would be calcium carbonate. Which statement explains the origin of a flame test color? Why is it that when we heat a metal ion, it gives a specific flame color? This is because when it is heated, electrons gain energy, jump to a higher energy level, so they become in what we call an excited state, but they don't like to remain like that. They need to go back to their original energy level. When going back to the original energy level, they emit the energy that was absorbed, and that is what we see as a flame color. So the flame color is actually the energy emitted. So electrons emit energy as they drop to a lower energy level. That's the color that we see. Sulfuric acid and sodium hydroxide react as shown. Which sample of sulfuric acid solution will be exactly neutralized by this amount of sodium hydroxide? So we want the number of moles. We need to get number of moles. Number of moles of the sodium hydroxide is concentration times volume. So from what we have, the number of moles is 0.1. Now, if we look at the equation, what would be the number of moles of acid needed to neutralize this number of moles of sodium hydroxide? Of course, from the equation, number of moles of acid is half the number of moles of sodium hydroxide, since from the equation it's a 1:2 ratio. So the number of moles of acid that we need is 0.005. And the question is, which of these choices gives a number of moles 0.005? And for each case, number of moles is concentration times volume. Please remember the volume is divided by 1,000 before you multiply it. So if we calculate the number of moles for each one, the one that gives 0.005 is that first one. The others are the wrong number of moles. A 20-gram sample of iron 3 sulfate was dissolved in water. How many sulfate ions are in the solution? Well, if we have 20 grams, I can get the number of moles. It's mass over the molecular mass, which is already given. So I have 0.05 mole of the iron 3 sulfate, but we're asked for just the sulfate. And you can see that the iron 3 sulfate actually has 3 sulfate ions. So each mole of the iron 3 sulfate gives 3 moles of sulfate. So we need the total number of sulfate is that number of moles times 3. So now we have the number of moles. Are we asked for number of moles or the number itself? How many ions? How many ions means I should multiply the number of moles by the Avogadro constant. So this would be the number of sulfate ions. Which substance is formed when concentrated sulfuric acid reacts with solid potassium chloride? Remember we said if sulfuric acid, concentrated sulfuric acid reacts with potassium chloride, it would give what? The potassium hydrogen sulfate and hydrogen chloride gas. And remember we said with the chloride, that's it. This is where we stop, because HCl is a weak reducing agent, so it would not go back and react with the sulfuric. While if we were talking about the bromide, we said bromides will form HBr, and the HBr is a little bit stronger reducing agent, so it will go back and react with sulfuric acid to form these products. Now, if we were talking about iodide, we said it will form hydrogen iodide. Hydrogen iodide is a strong reducing agent, so it goes on and reacts with the sulfuric acid and forms this whole lot of different products. What is the color of the solution formed when iodine dissolves in cyclohexane? If you notice, this question comes a lot in almost every paper. Remember, iodine dissolves in water and dissolves in organic solvents. And you should remember that when it dissolves in an organic solvent like hexane or cyclohexane, the color is purple. And when it was in solution, the color is a yellow solution. So remember, iodine in an organic solvent like hexane or cyclohexane, it has a purple color. Which alkane has the highest boiling temperature? Again, we said, what determines the boiling temperature? We said the longer the chain, that means more carbons, the higher the boiling point. So, more carbons, higher boiling temperature. And then, if they have the same number of carbons, then the straight chain has higher boiling temperature than the branched. So, if we're comparing number of carbons, the one that has more carbon has higher boiling point. If they have the same number of carbons, then the one that is straight will have higher than branched. So let's compare these. We have hexane, 6 carbons. Pentane, 5 carbons. So definitely comparing these two together, it's the hexane that is highest boiling temperature. And then the others have branches in them. So actually, the straight chain with 6 carbons is the one that has higher boiling temperature. What is the name of the alcohol shown? We said in order to name any organic compound, first we choose the longest chain. So where is the longest chain? 6 carbons, so this should be hex something, not pent or bute. So it's B or C, it's hex something. And then the ol or the OH is on carbon number 3 because we count from the side that gives the lower number. So here we're counting from the left. That will give the lower number for the substituent. So this is 3-ol, and that means that the methyl group is on carbon number 4. So this is 4-methyl hexane 3-ol. Chloroethane reacts with aqueous potassium hydroxide to produce ethanol. What is the role of the hydroxide ion in this reaction? So we're starting with chloroethane and we're reacting with potassium hydroxide, and this is aqueous. Remember we said halogenoalkanes with aqueous hydroxide produces alcohols. Now, what is the role of the hydroxide in this case? The hydroxide is attacking the slightly positive carbon to replace the Cl. This is acting as a nucleophile. So this is nucleophilic substitution when the halogenoalkane is reacting with aqueous potassium hydroxide. Which mechanism shows the correct movement of electrons? So what was happening here? We said this hydroxide attacks the carbon because it's slightly positive, and the electrons between the C and the Cl go to the slightly negative Cl. This question is about 4 organic compounds. Now, which compound would not give a color change when heated with acidified potassium dichromate? Remember, acidified potassium dichromate, first of all, it's orange. When it reacts, it changes from orange to green. Now, this is when it reacts with the alcohol. And remember that potassium dichromate will react with what? It will react with primary alcohols to give aldehydes and acids. It also reacts with aldehydes, of course, to give acids. And it will react with a secondary alcohol to give ketone. But the ketone does not react further. So, out of these choices, it is the ketone that will not react with acidified potassium dichromate. Primary and secondary alcohols react, aldehydes also react. Which compound could give peaks at m over z31 and m over z60? Well, let's take a look. If we look at propane 1-ol, can we divide it into a fragment that has a MR of 31? Well, yes. The CH2OH part will have an M over Z 31, and the total molecule is M over Z 60. So actually that is our answer. If you look at the others, they will not give these peaks. An IR spectrum for a compound containing one functional group is shown. Which functional group is most likely to be present? Again, we said when you're given an IR spectrum, the first thing you look at, do we have a peak above 3000? That peak above 3000, and it's usually a broad peak above 3000, that means I have an OH. So that means it's any of the functional groups that have OH. So it could be an acid or it could be an alcohol. Now we look at the area around 1700 and something. Do we have a sharp peak at 17 something? Yes, that is due to carbonyl or C double bond O. So if we have both of them and this is just one functional group, that means we have an acid. If it has only OH, then it's an alcohol. If it has only the C double bond O, then it could be the aldehyde or the ketone. But both, and it's one functional group, that means it is an acid. This question is about magnesium sulfate, a white ionic solid that is very soluble in water. Hydrated magnesium sulfate has the general formula, magnesium sulfate X water, where X is the number of water molecules of crystallization. A sample of hydrated magnesium sulfate was heated until all the water had been removed from the crystals. The mass of the sample decreased from 6.92 to 6.04 grams. First of all, state how you could ensure that all the water has been removed from the crystals. In this kind of reaction, we weigh the original hydrated salt, that means the salt and the water in it. And then we keep heating to get rid of all the water, and then the final mass would be the mass of the sample without water, which is the anhydrous part. So how do we know that all the water has been removed? We keep heating, cooling, reweighing until the mass no longer decreases. So we say we heat to constant mass. Calculate the number of water molecules of crystallization X. So we're trying to get X. What do we know? He said we started with hydrated, all of it, 6.92 grams. When we got rid of the water, the one left is 6.04, and that means I can get that the magnesium sulfate is 6.04 and the water is the rest of the 6.92. So the difference between them, that's 0.88, that was the amount of water present. And then I work with this as if I am trying to get empirical formula. That means divide first by the MR of each of them, and the numbers that come out you divide by the smallest. I find that this is a 1-to-1 ratio, and that means the X is 1, or the formula is magnesium sulfate H2O, just 1 water. The most common form of hydrated magnesium sulfate is the magnesium sulfate that has 7 water. The student carried out 2 experiments to determine the enthalpy change when anhydrous magnesium sulfate forms the magnesium sulfate 7 water. So we're trying to get the delta H for that equation where we change magnesium sulfate solid to magnesium sulfate 7 water. In the first experiment, the student determined the enthalpy change when dissolving anhydrous magnesium sulfate. So this is just getting the magnesium sulfate, putting it in water, and that means I just get the aqueous form. 100 grams of distilled water was placed in a polystyrene cup. The temperature recorded 0.0628 mole of the anhydrous magnesium sulfate was added to the water. the mixture stirred, and the maximum temperature recorded. So we have this temperature. These are the results for the temperatures. Now, calculate the enthalpy change for this reaction. So what do we have? To get the enthalpy change, we're supposed to say Q is equal to mc delta T, and then the delta H will be Q over N, right? So let's get Q first. What do we have? We have 100 grams of distilled water placed in a polystyrene cup and the temperature recorded, and that means my M is 100. Now, we know that the starting temperature is this and the maximum temperature is this, so I can get the delta T. So Q is mc delta T, so that is 100 times C is a constant 4.18 times the difference in temperature. This gives the quantity of heat in joules. Remember, what comes out from Q is in joules. I can then divide it by 1000 because usually we get the delta H in kilojoules. So how do I get delta H? Well, we are told that this is the number of moles of the magnesium sulfate. So the delta H is Q over N. So this gives a value of 85.2. Please remember, delta H must have a sign. So is it a positive value or a negative value? Well, we look at the temperature. The temperature went up. That means this is an exothermic reaction, and that means the delta H is a negative value. In the second experiment, the student determined the enthalpy change when dissolving hydrated magnesium sulfate. So now we're starting with the magnesium sulfate 7 water, dissolving it in water to get the aqueous form, and we're given the delta H for that. So complete the Hess cycle. What do we know now? We know that we can dissolve each of these in water. So dissolving the magnesium sulfate solid, that's what we calculated previously, that's minus 85.2. Dissolving the hydrated in water, that is delta H, that is given up there. So this is our Hess cycle, and we can use that to calculate the enthalpy change when anhydrous magnesium sulfate reacts with water to form the hydrated magnesium sulfate. So we're trying to get the delta H of that reaction on top. Well, follow the arrows and you will find that the delta H we're looking for plus the 15.8 is equal to the other one. Calculate for delta H, that comes out to minus 101. Magnesium sulfate is very soluble in water. Draw a label diagram showing how both the magnesium ion and the sulfate ion interact with water molecules. Remember that water has a slightly positive end and a slightly negative end. And that is because the oxygen is slightly negative, the hydrogens are slightly positive. Now, when we dissolve an ionic substance, the positive ions are surrounded by the negative end of water, and the negative ions are surrounded by the positive end of water. So the magnesium 2+ interacts with the oxygen, while the sulfate interacts with the hydrogen. Remember to put the slightly positive and slightly negative on the hydrogens and the oxygens. Barium ions are toxic in aqueous solution. If a solution containing barium ions enters the body, barium poisoning occurs. Describe how drinking magnesium sulfate can reduce the extent of the poisoning. So we're trying to remove the barium ions. If I react them with sulfate, you should realize that barium ions react with sulfate to form a precipitate. So this precipitate comes out of the solution, so this will prevent the poisoning. And the ionic equation for that is, of course, the barium ions, which are aqueous, with the sulfate ions, which are also aqueous, will form barium sulfate solid, and that precipitates out, so effectively removing the barium ions. This question is about two halogenoalkanes which have the structure shown. Name compound A. How do we name compound A? We look at the longest chain. So this is actually a prop single bond. So that's a propane. Now where are the substituents? I have an iodo on carbon number 2 and I have a methyl on carbon number 2. Now which one do we mention first? Do I say 2 iodo, 2 methyl, or the other way around? Remember, we arrange them alphabetically. So this is 2 iodo, 2 methyl propane. Draw the skeletal formula of B. How do we draw skeletal formula? Remember, each of these lines indicates 2 carbons on the ends of these lines. So between each 2 carbons, you draw a line. That's how we draw the skeletal. And of course, the chlorine is on the 4th carbon. Describe what you would observe when separate samples of A and B are warmed with silver nitrate. What was A? This was A and this was B. Now, if I react them with silver nitrate in aqueous ethanol, remember, silver nitrate is a test for what? Chloride, bromide, iodide. So A has what? A has iodide. It gives a yellow precipitate. What about B? It has chloride. Chloride gives a white precipitate. Give 2 reasons why A reacts more quickly than B when warmed with silver nitrate. Well, remember, A was this compound and this was B. Now, why is A reacting faster than B? Remember, there are 2 factors that determine how fast one halogenoalkane reacts with respect to another. So if we're comparing A and B, first of all, one of them is a Ci bond and the other is a CCl bond. And you should remember, going down group 7, the Ci bond is weaker and more easily broken than the CCl bond, because as we go down, the halogen is a bigger atom, less attraction between the bonding electrons and the positive nucleus, so the bond is weaker, more easily broken, so the reaction is faster. Another factor is it tertiary or secondary or primary? You should realize that A is tertiary, so it is more reactive than B, since B is a primary halogenoalkane. So remember, the CCl is stronger, reacts more slowly than a CBr and a Ci, and if it is tertiary, secondary, primary, the tertiary is more reactive. Write an equation for the reaction of B with an alcoholic solution of potassium cyanide and name the product. So B was this. So we want to react this with potassium cyanide. Remember that that means the Cl is replaced by a Cn, and the other product, of course, would be potassium chloride. Now, what is the name of that product? Remember, anything that has a C triple bond N is called a nitrile, and you add up all the carbons, including the carbon that has the Cn. So we have in that product a total of 5 carbons. So this is called pentane nitrile. Again, you count all the carbons, including the one attached to the nitrogen, and it is called something nitrile. So just why this type of reaction is important, remember, we started with something that has 4 carbons, now we have 5. So actually this reaction is used to add an extra carbon to the chain. When I want to increase the number of carbons in the chain, we react the halogenoalkane with a cyanide. A student determined the molecular mass of an unknown volatile organic liquid X using the apparatus shown. The student used a hypodermic syringe to inject a sample of liquid X into a gas syringe. The gas syringe was placed in an oven and the liquid vaporized, and we have these results. Now the question is, first of all, calculate the relative molecular mass of liquid X. Remember, if we have a gas, remember the liquid was vaporized, so actually we're talking about a gas. Then we can use PV is equal to nRT, get the number of moles, and then I can use that to get the MR. So let's get the number of moles. Number of moles is PV over RT, and you get the information from that table. Now, what is the pressure? Well, we're given the pressure of gas in the gas syringe 99 kilopascal. In order to put it into the equation, it has to be in Pascal. So multiply by 1000 or multiply by 10 to the power 3. Now, I want the volume. I'm given the volume of gas syringe after X had been vaporized, 81 centimeter cubed. In order to put it into this equation, it has to be in meter cubed. Meter cubed means I multiply by 10 to the minus 6. Over R is 8.31, and the temperature, we're given the temperature of the oven in degrees Celsius. We have to add 273 in order to make it in Kelvin. So overall, that is the number of moles of the gas. Now we're asked for the molecular mass. You should know that molecular mass is the mass over the number of moles. We are given in that table again, the mass is 0.12 grams over the number of moles we calculated. That means the MR is about 46. Each molecule of X contains carbon atoms, hydrogen atoms, and 1 atom of oxygen. Identify what is X. So if we have carbon and hydrogen and oxygen, and we just calculated the MR to be about 46, this could be C2H6O, which is probably ethanol. This question is about group 7 hydrides. The table shows the boiling temperatures of some group 7 hydrides. So we have boiling temperature of HCl, HBr, and HI. The increase in boiling temperatures in these hydrogen halides is due to London forces. So the question says, describe how London forces arise. So what are London dispersion forces? You should realize that these are interactions between simple molecular structures due to what? Due to the fact that they distort each other's electron cloud. This causes instantaneous temporary induced dipoles. So one end becomes slightly positive, the other end becomes slightly negative, and there is attraction forces between these opposite charges, and that is what we refer to as London force. State why London forces in hydrogen iodide are stronger than those in HCl and HBr. Remember, as we go down group 7, the atom becomes bigger, larger number of electrons, so the electron cloud distortion is a stronger interaction. So more electrons in the electron cloud, this causes more distortion and stronger London dispersion forces. The boiling temperature of hydrogen fluoride is plus 20. State what causes hydrogen fluoride to have such an unusually high boiling temperatures. Remember, among all the hydrogen halides, hydrogen fluoride has the highest boiling temperature compared to HCl, HBr, and HI. So we said HCl, HBr, and HI, the boiling temperature is gradually increasing due to the increase in number of electrons, and therefore stronger London dispersion forces. But HF is different because fluorine is a very electronegative element, so actually the hydrogen fluoride molecules have hydrogen bonding between them, and these are stronger and need more energy to be broken than the simple London dispersion forces between the other hydrogen halides. Chlorine reacts with water as shown. Explain why this is a disproportionation reaction. Again, what is disproportionation reaction? It means one species is both oxidized and reduced in the same equation. So here we have chlorine changing to two different species. Each of them has different oxidation number. Remember, chlorine as a molecule has oxidation number 0. Now, when it becomes HOCl, the Cl has a +1 oxidation number, and that means the oxidation number has increased from 0 to +1. That's oxidation. It also forms HCl, in which the chloride has an oxidation number of -1. So now it's decreasing from 0 to -1. That is reduction, and that's why we say it is disproportionation, because chlorine is both oxidized from 0 to +1 and reduced in the same reaction. State and explain what happens to the position of equilibrium when sodium hydroxide is added. This was the equilibrium equation. Now we're adding sodium hydroxide. You should remember sodium hydroxide, of course, is a base. So when we add it to this mixture, it will react with the acids that are formed. So basically, we are removing the products as they are formed, and that causes the equilibrium reaction to go forward or to shift to the right to make more acid. Remember, as we remove products, reaction shifts to the right to give more of the products to return back to the state of equilibrium. This question is about lithium and some of its compounds. Lithium has an atomic number of 3 and is the least dense of all the solid elements. Lithium hydroxide solution can be made by reacting lithium with water. Remember, lithium is in group 1. Group 1 reacts with cold water. We are required to write an equation for that reaction. You should know that group 1 metals react with cold water to form the hydroxide plus hydrogen gas. Lithium, of course, is a solid. Water is a liquid. We are required to include state symbols. Lithium hydroxide is aqueous and hydrogen is a gas. Please do not forget to balance the equation. Remember, there are 2 hydrogens before the arrow, 3 hydrogens after the arrow, so we need to put a 2 in front of the water, a 2 in front of the lithium hydroxide, and a 2 in front of the lithium. Please balance the equations. Give 2 observations you would make. Now, something that gives out a gas, of course, the first thing we write is bubbles of gas or fizzing. And another observation, lithium also floats on top of the water. All group 1 will float on the water. And if we compare lithium with sodium with potassium, of course, the reactivity increases as we go down group 1. So sodium, the bubbles of gas catch fire. Potassium, it's very vigorous and the bubbles also catch fire, and we get a lilac flame due to the burning of the potassium. Lithium metal is stored under oil. When a piece of lithium metal is removed from the oil, the surface quickly tarnishes. One compound formed is lithium nitride. State how lithium nitride is formed. Where would the lithium nitride be formed from? Of course, from the reaction of lithium with nitrogen in the air, and we're required to include the formula of lithium nitride. Of course, the valency of nitrogen is 3, so we put 3 under the lithium. Mobile phones rely on rechargeable lithium batteries. The cell of one type of battery consists of an anode containing a compound of lithium and a cathode containing cobalt oxide. The 2 electrodes are kept apart by a separator. When the cell is in use and current flows at the anode, the lithium atoms lose electrons and form lithium plus ions. The ions travel through the separator and the electrons travel through the external circuit to the cathode. At the cathode, cobalt oxide combines with the lithium ions and electrons and forms this compound, and we're given two reactions. So the next question is, give the overall equation when the cell is being used. Well, we're given the two half equations. How do I get an overall equation from the two half equations? We said we add them up. Whatever is the same on both sides of the arrow, we cancel, and we just write down whatever is left. So that is the overall equation. Describe with reference to oxidation numbers what happens to the cobalt. Well, the cobalt changed from COO2 to lithium with cobalt with oxygen. If you calculate the oxidation numbers, you'll find that it has changed from +4 to +3. This is a decrease in oxidation numbers, so the cobalt was reduced. State one property the separator must have to ensure the lithium battery is viable. Of course, when we were explaining, he was saying the ions should pass through, so the separator there should be porous to allow the ions to pass through. Lithium is often added to aluminium to make aluminium-lithium alloys. These alloys have a variety of uses, including aircraft manufacture. One alloy contains aluminium and lithium, and it contains 2.45% aluminium. So calculate the molar ratio of aluminium to lithium. So of course we're starting with 2.45% of lithium. The rest of the 100 would be the percentage of aluminium. And then we go through as if we are trying to get the empirical formula. Divide first by the mass number of each one. The numbers that come out, we divide by the smallest, and that gives a ratio of about 10 to 1. So that is the ratio of moles of aluminium to lithium. Suggest a reason why this alloy is better than pure aluminium. Why are alloys more useful than the pure metal? You should realize pure metals have layers of positive ions that can slide over each other, so metals are malleable and ductile. But when we have alloys, remember that an alloy is made of atoms of different sizes that do not allow the layers to slide over each other easily, so alloys are stronger and less dense than the pure metal. They are also more resistant to corrosion. Compounds of lithium and compounds of magnesium have similar properties. The ionic radii of lithium and magnesium ions are similar. The thermal decomposition of lithium nitrate is similar to that of magnesium nitrate, but different from the thermal decomposition of sodium nitrate. Now, we're asked to explain why, first of all, and include relevant chemical equations. So, let's compare lithium and magnesium. You should remember that. Magnesium ions have one more shell than lithium, but they have a higher charge, and that is why the sizes are almost the same. So the higher charge causes more attraction between the shells and the positive nucleus, so magnesium actually is about the same size as lithium. Now, magnesium ion is smaller in size compared to the sodium ion. So when we're comparing magnesium 2+ and sodium Na+, the magnesium ion is smaller again because same number of shells, but the higher charge in the magnesium ion causes more attraction between the shells and the positive nucleus. So the magnesium ion is smaller, and that has more polarizing ability, and that is why the magnesium nitrate would break up more easily than the sodium nitrate. Now we need equations. The magnesium nitrate and the lithium nitrate both break up when heated to form the oxide plus nitrogen dioxide plus oxygen, while sodium or potassium nitrate, remember, when they are heated, they form the nitrite plus oxygen. And that's the end of the paper. I hope it was useful to you, and good luck in your exam.